This is Mr. Chu. In Bare Algebra, we have lesson 6.03c, which is the challenge problems worked from lesson 603b. So we're taking two equations and figuring out what their solution is, which means if I were to graph them, I would know exactly where they intersect. This is used a lot in business, and you use the solving systems by substitution if you've got y equaling some value, and you can plug in for y, and if you've got x equaling some value, you can plug in for x. So I have one of each kind. So let's just get right to it. So I take this top equation, and instead of writing 4y, I write 4 times parentheses negative 3x. So let's start over here. And I substitute negative 3x here. 32. All right, now I have to simplify 4 times negative 3x, but it's really negative 4 times negative 3x. So that becomes a positive 12x equals 32. Now I have to simplify this equation. I have like terms, values of x. So 4x plus 12x is 16x, and that equals 32. I don't want 16x's, I just want x equaling something, and that would be my x coordinate. So what do? I use the division property of equality. So I divide the left by 16, and I divide the right by 16. 16 over 16 is 1. 1 times x is x. 32 divided by 16 is 2. So what does that mean? That means that the x coordinate is 2. So that means that the solution is going to be the point 2 something, but I don't know what that something is. And I can find that now by substituting. So now I'm going to substitute a 2 into either one. So I'm going to substitute x equals 2 in what? In the one that's easiest. Well, the bottom one's easier. Y equals negative 3x. So now substitute that value. Y equals negative 3 times 2. So y equals negative 6. So if x is 2 and y is negative 6, then the point 2, negative 6 is my solution. But I could have made a mistake. So what do? I'm going to check it. So to check this now, you're going to substitute in both equations. I'm going to substitute 2, negative 6. So I take my top equation, 4 times 2 minus 4 times negative 6, and I'm asking, is that equal to 32? And if it is equal to 32, then I know for a fact that that point, 2, negative 6, will be on that top equation. So I simplify now, and I do the order of operations, which means I multiply before I divide. And a negative 4 times negative 6 is 24. Does 8 plus 24 equal 32? It sure does, and if you need to get to this point, do it. What does that mean? That means that this point is on the top line, but I don't know if it's on the bottom one or not. So what am I going to do? Now I'm going to substitute into this second equation, and I'm going to put a 2 where the x is and a negative 6 where the y is, with a question mark. Does negative 6 equal negative 6? Yes, it does. So what does it mean when they both check? It means that's where the two intersect. And if you were to graph these, and I'm not graphing them right now, but wherever that would be the point 2, negative 6. All right. So in this equation, I've got x equaling something. So in my bottom equation, I'm going to substitute 3y minus 2 in for x. And it just makes the equation a little bit harder to solve. Why does it make it harder to solve? Because this has two terms and is a binomial, where here it was just a monomial. So I know you're saying, well, I don't know what all those nomials mean. Well, that's fine. Let's just take this equation now, and where there's an x, substitute 3y minus 2, and then solve it step by step. So I have 9, and then I have my 3 minus 2, where I use the substitution property of equality, plus 6y equals 48. Now, I had some earlier videos on this. Whenever you've got a number out inside of a parentheses that is an algebraic expression, you have to multiply that 9 by both things. It's called the distributive property. So I have 9 times 3y minus 9 times 2 plus 6y equals 48. So now this equation will just be a little bit harder to solve. Not real hard, but just a little bit harder. 9 times 3y is 27y. Minus 9 times 2 is 18 plus 6y equals 48. Now before I can solve this, I have to do the bidistributive property and now simplify and now combine like terms. So you notice I got y's here and y's here. So 27y plus 6y is 33y minus 18 equals 48. Now this is no different than some of the other equations we've had. So I need to undo subtracting 18 from the left and use the addition property of equality. So I add an 18 to this side, and I add an 18 to this side. It crosses out here because I get a 0, and 33y minus a 0 is 33y, and that equals 66. I don't want 33y's, I want y. So I divide both sides by 33. 33 over 33 is 1. 1 times y is y, and it equals 2. So I believe the solution is going to be an x value and the y value of 2. I don't know what the y value is, but I can substitute y equals 2 in the easiest equation. Which one's easier? I believe the top one is. You can use either one. So let's use the top one. So x equals 3 times 2 minus 2. X equals 6 minus 2. So x equals 4. So I believe that the solution is 4,2. Now, do you really think it's 4,2? I don't know, but I can check it by plugging them in. So the hardest one to check is going to be the bottom one. Let's do it first. So I have 9 times 4 plus 6 times 2. Does that equal 48? And if it does, then it means that 4,2 is on that second equation. So 36 plus 12. Does that equal 48? When I multiply 9 times 4, I get 36. 6 times 2, I get 12. When I add them together, do I get 48? I sure do. 48 equals 48. What does that mean? That means that 4,2 is on that second line. Now I have to go and check and see if it's on the first line. So I take my x equals 3y minus 2, and my x is 4. And does that equal 3 times my y is 2 minus 2? 4, does that equal 6 minus 2? Well, 4 does equal 4. So since they both work, it means that that is the solution to that system of equations. Right where those two lines intersect is that point. So the original lesson, if you needed to see more examples, we'll have a link up here. Down here will be a playlist which will have all of Unit 6 on our systems of equations and inequalities in it. I'm Mr. Chu. I call this Bear Algebra. I want you to bear with me while I teach you algebra so that you can remember it. See you next time in the next video. Subscribe to my YouTube channel.